Welcome to the showcase for Cloudera Altus on AWS and Microsoft Azure. So Cloudera supports 4 different types of application patterns. We support data engineering for ETL and model training type of workflows. We support data science for ad hoc data discovery and model training. We do analytics database, which is a SQL-based engine and approach for ad hoc queries of data, as well as visualization and applications to help you visualize. We also support operational database, which is real-time streaming and real-time analytics. All of these 4 different types of applications are supported today on-premise and in the cloud. However, in the cloud, there are different types of mechanisms of using the cloud infrastructure, so you can get on-demand capacity and have the agility for your end users to get Cloudera capacity when needed. The first thing is that there is hyperscale cloud storage, which is highly scalable, 11.9's resilient, and cheap relative to other forms of storage. And with hyperscale cloud storage like AWS S3 or Azure Data Lake, you can start scaling your compute and your storage independently. With your data on an external storage system, you can also spin up compute capacity when needed. You can spin up compute capacity to process your data, basically grow and shrink your different clusters, and then terminate the clusters when you don't need them anymore. And because of this, you can compartmentalize your different types of workloads into different clusters. An example workflow for using Cloudera in the cloud. On the left-hand side, you can see data getting ingested into hyperscale cloud storage, again, whether that's S3 or ADLS. And then you can use Cloudera Altus to spin up data engineering clusters, such as Spark or MR2 or Hive on Spark, that can do the data processing from raw data into structured, clean data that can be used later for analytics. One common analytics engine that people use is Impala, which will be for ad hoc queries and also for BI types of use cases. Impala is not today supported on Altus, but you can use Director to spin up Impala clusters, and then the end user can visualize this data through Impala and their BI visualization tool of choice. So Altus is a platform as a service offering that hosts the Cloudera family. Platform as a service means that it's a managed service that removes cluster operations. So you don't have a lot of the overhead of managing a cluster yourself. We manage the provisioning plane. Cloudera manages the provisioning plane as well as the clusters that are deployed and configured through Cloudera Altus. You don't have to install any kind of software to use it unless you want to. You don't have to worry about cluster configurations. There are intelligent default configurations for all the instance types that we support in the various clouds. There's no upgrading or OS patching. We own the images that we actually deploy into the cloud infrastructure. Without having to worry about cloud operations, then users can focus on their end user pipeline. So they can focus on the applications that they care about. So for the data engineering workflows, we have jobs as job submission APIs, so that jobs are first-class objects within the system. You'll see a full list of all of your job histories. You can determine which of the jobs failed and easily remediate these jobs and rerun the jobs again. We provide mechanisms for you to troubleshoot these jobs. While the cluster is running, you can use Cloudera Manager, which is basically can be used as a monitoring troubleshooting tool. We also have workload analytics, which is native to the cloud. To date, Cloudera Altus has supported AWS as a cloud infrastructure platform. We announced at Keynote that we will shortly be supporting Azure in beta form next month. And in Azure, you'll have the same data engineering capabilities as you do on AWS. Altus was designed to be multi-cloud from the outset, so it will support multi-cloud workflows in a very native type of way. In Azure, you would store your data in Azure Data Lake so that you would have all of your data growing as you're ingesting into Azure Data Lake and spin up compute as necessary in order to process this data. They would all be sharing all of this data in your data lake. The clusters themselves that are spun up to process this data run in your Azure subscription, and we provide a single pane of glass through Altus so that you can see all of your clusters that are either in AWS or Altus. So I'm going to show a demo today of Cloudera Altus. What I'm going to show is basically a correlation between hospital mortality rates and state GDP. And in order to do this, we basically ingested data from Medicare.gov for the mortality rates and per capita state GDP from Wikipedia into AWS S3 and also into Microsoft ADLS. We'll use Altus to spin up clusters for data engineering in AWS and in Azure. And with these data engineering clusters, we'll run jobs so that we'll take all of this raw data that has been ingested into the storage system and create nice, well-formatted, structured data. And we'll use Cloudera Data Science Workbench to be able to visualize this data. So this is Cloudera Altus, our managed service offering. When you first log into Cloudera Altus, you'll see the home page. On the right-hand side is everything about what's new, so all the major features that have come in say, the last 2 to 3 months. We announced support for Cloudera Navigator lineage, so you can see lineage across multiple data engineering clusters in AWS. We have new support for CDH 512, and we support machine users in the system. So if you have some programmatic uses that you don't want to actually have users that are logged into the system, you can have these machine user accounts. In the center is basically a summary of the activity that has occurred within this particular account. So you can see that there's a summary of the running jobs, running clusters and environments that are available here. You can see that there were 2 jobs that were run in the last 24 hours, and you can see all the clusters that are available in this particular account for processing. If I click into environments, the environments map into AWS and Azure accounts to which you want to deploy your clusters. So typically people segregate their accounts for isolation purposes for different types of environments like dev, test, prod in AWS or in Azure. And from a single Altus account, you can provision into multiple different types of environments, including on multiple clouds now. Once the environments are set up as a one-time setup from an administrative point of view, then you can give the environments to your data engineers, and your data engineers can start spinning up clusters and running jobs. So here you can see that we have multiple clusters for AWS as well as for Azure. To create a cluster and get more capacity in the cloud, this is a very simple process. You can simply put a cluster name, a service type, which CDH version you want to use, an environment that you want to deploy into, and then you specify the node configurations for your cluster. So minimally, you need to have 3 worker nodes. You can specify if you want spot instance types. You choose a particular private key so that you can SSH into the cluster after the cluster has been provisioned. And then you put in username and password for Cloudera Manager, which is in read-only mode when you deploy it with the cluster, and that's it. So that's all it takes in order to create a cluster in a CDH cluster in a particular environment. So if I want to submit a job, I can first submit this job into AWS. And if I want to submit a job, the fastest way for me to do this is to just clone this particular job. And remember, I'm going to take some raw data from Medicare.gov and from Wikipedia, and I'm going to process this data. The data is resident in S3. I'll read the data from S3, do the processing, and then write the data into the output directory. So here you can see I have a Spark, job that's named demo, and it has a class that comes in a jar file that is resident on S3. We use the S3A Hadoop connector to be able to read and write from S3. I have input arguments where my input data is coming from, and output where I'm going to write directly the output of this data transformation. And then I can pick a particular cluster that I want to basically use to process this data, and then I can submit the job. So here you can see that the job demo has been submitted. If I look into the AWS console, then I can see the area where the data is actually stored. So if I look inside the input directory, it's picking up this mortality rate data as well as the GDP.txt, which is the raw GDP data. If I look into the program directory, this is where the actual Scala application resides. And then when the output is done, there will be an output directory that has all of this cleaned, structured data. So we can check to see if this. So you can see that this job is actually running. And while the job is running, it's very easy to look into Cloudera Manager. Cloudera Manager is our system management platform that we use on-premise. And you can also now use it in cloud in read-only mode in order to view the status of your jobs. So if I look inside Yarn applications, you can actually see that this job is executing on this particular cluster. And if you want to do some type of troubleshooting with this job, you can go into the log files by clicking onto these various links. You can see all of the component UIs as well through Cloudera Manager. So this job takes about a minute to run. And then after the job is done running, you'll see the job completed on this job form. If I look at an old completed job, you'll see workload analytics. So these are the details of the jobs themselves. It was the same job that is typically run on a recurring basis. And then if I look in job analytics, I can troubleshoot this job through execution details. You'll also see that we baseline jobs, recurring jobs. Once you've run a job 3 times, then we'll baseline this particular job. So here's the health checks. Execution details will give you all of the log files. And then we'll also do baselining and deviations from the baseline with some root cause analysis if things have gone wrong. So this is the baselining capability. This is baselining capability, and you'll see deviations from the baseline. And it'll give you some troubleshooting capability and root cause analysis if the performance isn't as performant as usual. Anyway, we'll go back to the job. We can see that it's completed. If we look in S3 and we refresh this page, we should see an output directory with cleaned data. If I want to run the same job, it's a very easy thing to do. If I want to run the same job on ADLS, I can simply clone this particular job. And then instead of specifying S3A URIs, then I can specify ADLS locations. So I have this jar file on ADLS as well. So I can specify an ADLS location. I need to specify an input and an output directory. So here I'll specify an input directory that has an ADL path and an output directory. And you'll see I'll put this into the output JWoo1 directory. I need to specify an Azure cluster. And then this is going to run in the Azure environment. And if I look inside the Azure ADLS URL, you can see that I have the same data that's inside Azure. I have jar files that specify the program itself. And then I'm going to have an output directory that will have my initials JWoo on this directory when it's done. So this application takes about a minute to run, and then we should see the output shortly. Still waiting for it to run, I believe. So the difference between running jobs inside AWS and on Azure itself will just be simply specifying different URIs as long as the application is independent of the particular environment. The job says it's completed. If I look inside Altus Demo, you'll see my initials here with all of the data here successfully converted. So if you are interested in participating in the Microsoft Cloudera Altus Beta. You can request access on the cloudera.com website, or feel free to stop by the Cloudera booth. Thank you.